Hello gentlemen, welcome to our video on section 7.3 entitled Thermochemistry and Cooking Fuels. Now in the investigation for this section, whether you've done it already or you have not, it's based on burning fuel. So fuel is going to be burned, and when that happens, energy is put to use. That energy that we're using is used to raise the temperature of the water in your Coke can. You have to remember that temperature is simply a measure of the average kinetic energy of the system. So as heat's added to that system, kinetic energy increases, thus your temperature is going to increase. You have to remember that heat is a measure of the total energy in a system. Heat can be measured in what we call calories, I'm sure you heard that word before, and or joules. We'll be using joules mostly in this class. Now a calorie with a lowercase c is the amount of heat needed to raise the temperature of 1 gram of a substance by 1 degree Celsius. In this case, we're going to be talking about the substance water. So the amount of heat needed to raise the temperature of 1 gram of water by 1 degree Celsius. Now a different calorie, the one that we're most familiar with, is the one with the uppercase c. Now, these are food calories. They're related to this calorie, the lowercase one, in this way. 1 food calorie equals 1,000 lowercase calories, which we abbreviate as cal. So if you're consuming, 500 calories from food, that's 500 times 1,000 calories, for energy. We can also express this in, 1 kilocalorie is also 1 big C calorie. And again, food calories is just a measure of the energy available from your foods. Internationally, people don't use calories to talk about energy. Usually the unit that's used is the joule. And to relate calories and joules, 1 calorie equals 4.184 joules. Now, in your investigation, what you were to do was to calculate the amount of heat that was consumed per gram of your fuel. So calculate the amount of heat or the amount of energy that was consumed for every gram of the fuel you used. What you needed to measure to actually calculate this was your mass of your water, which is going to be equal to the volume of your water, the change in temperature of the water, so when you first started the experiment till after, how the temperature of the water has increased, and then lastly, you had to show how the temperature of the water changed relative to the amount of water you had, so the mass of water. And you can show this relationship with something called the specific heat capacity. Now, specific heat capacity is the heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius. Well, that sounds exactly what we just said in the last board, right? It's the same definition of a calorie. So specific heat capacity is the heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius. Now, in this experiment, we were using water as our substance. So for water, it takes 1 calorie, or 4.184 joules of energy to raise the temperature of water by 1 degree Celsius. So if I have 1 gram of water, just 1 gram, I need to put in 1 calorie of energy to raise that water's temperature by 1 degree Celsius. We can display that with this fraction here. It takes 1 calorie per gram per degree Celsius. Or it takes 4.184 joules of energy for 1 gram to increase by 1 degree Celsius. Same thing. Now, these numbers are specific for water. Every other substance has its own unique specific heat capacity, meaning the number for different substances will change. For example, aluminum is around 2.7, not 4.184. They will change. Now lastly, we can represent heat symbolically as Q. Sometimes you'll see it as a lowercase q or an uppercase Q. And we can start to quantify the amount of heat transferred using this equation. Q equals mcΔT, often said as Q equals mCat. Now Q is the heat gained or lost. If heat is gained, you'll end up with a positive Q value. If heat is lost, meaning it's exothermic, you'll end up with a negative Q value. M is your mass of your substance. So in this case, we're using water in our substance. You'll just put your mass there in grams. C is your specific heat capacity, what we just talked about on the last board. It's going to be a constant, something that you can look up or is already known to you, or it will be the variable that you solve for in the problem. So it's not something that you have to just kind of figure out. It's something that's known. For water, it'll always be 4.184 joules per gram degree Celsius. Delta T, this little delta symbol, this triangle here, means change. So it's a change in temperature. What that means is delta T is your final temperature minus your initial temperature. Because you started somewhere and you finished somewhere. To find your change, you take where you finished, and you subtract from it where you started, and that gives you your delta T. So in any given problem, you'll be given, 3 of these variables, and you'll solve for the 4th one that's the unknown. So gentlemen, please take notes on this. Be prepared to use this. Adios.